this. Let's close this out. We got this Excel sheet right here. We're finding out basically if this company, Guest Tech, who provides high-speed internet, is able to continue to charge 10 cents per room per day. It's extremely aggressive pricing, and their competitors are curious if they're going to be able to last. The first question asks, using the information provided, plot the total cost curve as a function of the total number of hotel rooms served. So immediately what I did was I created a total cost right here, which basically just adds the variable costs and the fixed costs for each quarter, brings it all that to this, and then we bring that information over here along with the average rooms serviced in that quarter, and then we plot that into a scatter plot, which gives us this function, which is a total cost function. Question 2 then asks, compute the average total cost per unit as volume changes. Bring that same information down here, but we create this function right here. It's a cost per unit function, so it takes P51, which is the total cost, multiply that by 1,000, which brings it to the actual revenue that it was, since these numbers are actually in thousands, and then we divide that by 0.51, which is the number of rooms serviced, times 365 over 4, which gives us a rough estimate of what a quarter would look like, which is around 90 days, 91 days. And that brings you to your cost per unit. Obviously, as the company services more rooms, they're in economies of scale at this time, or I guess we'll go over that in a second, but they're in economy of scales, so their cost per unit decreases. Question 3, plot the unit costs and fit an appropriate scale curve using Excel's curve fit power function. So right down here in question 3, we have the unit costs graph. We have the average room served on the x-axis and the costs per unit on the y-axis. So basically, it's going to show us how, at least during the time that we've been given, this 2004 to 2007 data, as the average room served goes up, the cost per unit goes down. And we can see that it continues in economies of scale this whole time. We don't ever reach that flat point or that diseconomies of scale. And it also gives us this function right here, this equation I should say, which represents that we are in economies of scale during this time. Question 4 asks us to, it says if Guest Tech wanted to operate at a total cost of 15 cents per room per day, how many hotel rooms will they need to have in a contract? And the same thing with 20 cents. So simply for this, what I did is I took my function right here, I plugged in the 15 cents per day that they would have to, that it would cost, to the x to the negative 0.559, gives you 1,094,271 rooms. Same with 20 cents, 654,065 rooms when you round those numbers up. So that's how many rooms you would need to operate at 15 and 20 cents cost per room per day. Or to get that, I guess, to give a little more context, that's to get the unit cost to that. That's how many rooms you need to be servicing. Question 5 then asks, by how much do Guest Tech unit costs fall with each doubling of output according to scale? So this one is actually pretty simple. So we're trying to find the doubling. So you take this factor right here of negative 0.559, and you actually just put 2, and then you raise that to the 0.559, and it gives you this percentage. And then you subtract 1 minus that percentage, and it gives you this percentage. And this percentage, 32.1%, is how much unit costs are falling when you double your output. So basically, when you go from 100 to 200, you're going down by about 32%. And that's obviously on average, given this function. But yeah. Question 6, I guess real fast, another way that you can solve that is you can literally input information like 1,000 or 2,000, and you can see. But another way to solve it is to just do 2 raised to the power of the exponent from your unit cost function. Anyways, back on track to question 6. It says, given the current cost situation, would you recommend that Guest Tech continue pricing at 10 cost per room per day? Do you have enough information to answer this question? So I'll just read out my answer. I said, with what we are given, it seems that costs can infinitely fall. If you keep pricing at 10%, you will eventually have enough sales that you can make a profit. However, this isn't pretty realistic. We don't really have enough information because the more rooms that you serve, the higher fixed costs get, higher variable costs might even get, and eventually you're going to enter diseconomies of scale, and your costs will likely never actually get below 10 cents. We also don't know how long you can survive at a deficit, if you would even be able to wait long enough till you service enough rooms. So technically speaking, just given this function, it appears as though you would be able to charge 10 cents per day. But the further that you go, it's actually likely that your cost per unit is going to start going up again based off of economies of scale. Question 7 says, now compute guest tech's marginal costs at various different room value counts. What I did for this, so it gives you two options. You can do the first derivative or you can make a table. I did both just to check my answer. So the first derivative of our total cost function is, so this is our total cost function, and the first derivative of that is this 14.3524 over x to the 0.5587. And I just plugged in a bunch of different numbers, so like 100,000, 200,000, 300,000, just to see where the unit costs were going, or excuse me, the marginal costs were going. Obviously, as you service more rooms, it keeps decreasing. The numbers, I guess the latest that the company ever got to was about 520,201, and the marginal cost at there is just barely above 10 cents per room. Similarly, there's the table method where you just use that total cost function and you put numbers that were right next to each other, so 100,000 and 100,001 rooms, and I put in this fancy function right over here. Basically what it's doing, you have P99, which is the number of rooms that you're servicing, and you just plug that into your total cost function right here, and then you multiply it by 1,000 since our revenue and our costs were in thousands, and then you divide it by the quarterly amount, and that gives you this much. And you do that for the next unit up, it gives you this much. Subtracting those, you get about 25 cents marginal cost at 100,000. You get 17 cents at 200,000, and you can see that these numbers are consistent, so you know that your marginal cost is correct. Question 8 then says, given guest tech marginal cost, can they afford to price at 10 costs per room per day? Do you think they should price at this level? Why or why not? I said with the amount of rooms they currently service, guest tech cannot afford to price at 10 cents per room per day. They haven't currently broken the threshold required for their marginal cost to be less than the revenue per room per day. Additionally, even if they do, their profits will be very minimal, and they are likely already approaching diseconomies of scale. Question 9. What do you think guest tech should do if they want to drive their total costs down even further? In an ideal world, if they want to drive their unit costs down even further, they should keep sales efforts high to maximize the amount of rooms they service before entering diseconomies of scale. Obviously, the more rooms that they serve, the less the unit costs for fixed costs are, and their unit cost per room is going to decrease. So that is how it would work in an ideal world.